Hi, welcome to this video in data exploration. In this video, we'll move to the last step in data exploration, that is variable transformation. Let's look at the different topics that we'll be studying in this video. First of all, we'll have a look at what is variable transformation. Then we'll see why do we use variable transformation. And then we'll see the common methods of variable transformation. So let's move on to what is variable transformation. Variable transformation is the process by which we replace a variable by some function of that variable. For example, we can replace a variable x with its logarithm. Also, when we introduce this change in the dataset, then the relationship between two variables change. So for example, if a variable x had a linear relationship with a variable y, by replacing the variable x with its logarithm will change the relationship between the two variables. So why do we use variable transformation? Variable transformation is used when we want to change the scale of a variable. So for example, if there are 11 variables in your dataset, and 10 variables are measured in kilometer, while the 11th variable is measured in miles. So this difference of scale can cause error in making accurate predictions. So we convert back the variable which is in mile to kilometers using the variable transformation. We also use variable transformation when we want to convert non-linear relationships into linear relationships. Here is an example of when a non-linear relationship is converted into a linear relationship. So why do we do that? It happens because linear relationships are easy to comprehend than non-linear relationships. And these transformations help us convert the non-linear relationships into linear relationships. Also, variable transformations are used to create symmetric distributions from skew distribution. So this is on the left is a skew distribution, and this is on the right is a symmetric distribution which is created from this skew distribution. So why do we create symmetric distributions? It is because symmetric distributions are easier to interpret and generate inferences. Also, symmetric distributions of variables help us conform to the assumption of many models which require normally distributed errors. So when variables are normally distributed, it helps in getting normally distributed errors. So that is why we create symmetric distributions. So now let us look at the common methods of variable transformation. So the first method is logarithm, where we take the log of the variable. Taking log of the variable reduces the right skewedness of the variable. So if you remember our previous lessons, so right skewedness is when majority of the values are concentrated on the lower side and there are very few large values which drag the tail to the right side. So for example, here majority of the values are on the lower side and there is a single value which is on the higher side. So this is a right skewed variable. Logarithm reduces this skewness. As you can see, now the ranges of variables have changed. The smaller ones have increased in magnitude in comparison to the larger one. Next are the square root. Square root transformation also helps us in reducing the right skewed variable, but this is only applicable when we are using positive values inside the variable. So this doesn't work when the variable has negative values. So for that purpose, we use cube root transformation. Cube root transformation can work with positive or negative values of any right skewed variable. The last one is binning, where we convert continuous variable to categorical variables. So for example, this is an example of binning. This is the age variable where we have age ranging from 10 to 90. Here we have converted this continuous variable into bin. So for example, this yellow part is a single bin called A, red part is another bin called B, green part is C, and this violet part is D. So this was all about variable transformation. In the next video, we'll see how we can implement these variable transformation techniques in Jupyter Notebook. Thank you.